This is the last video for exercise 5.1.3. So now this is part 4. And where I left off in the previous video was I now have grouped all the terms in X, and now I've combined all of those coefficients that are multiplied by each of the terms and reduced it with basically a geometric sum into this form right here. And what I want to do is just kind of clean this up just a little bit more such that the time evolved wave function is 1 over pi to the 4th, this sum, where now I'm going to pull out, I'm going to break up the this term with 1 plus alpha into a 1 over the square root of 1 plus alpha. So that's that minus 1/2 exponent times a 1 plus alpha to the minus r times x to the 2r power. So that's multiplied by the end of this thing right here. Okay, since there isn't any r in this 1 over a square root of 1 plus alpha, I can pull it up front. So I'm left with 1 over pi to the 4th times the square root of 1 plus alpha times the sum of r going from 0 to infinity minus 1 to the power of r x to the 2r divided by 2r r factorial 1 plus alpha to the power r. Okay, so now I can take this summation and turn it into an exponential. So I have 1 over pi to the 1/4 square root 1 plus alpha e to the power of minus x squared divided by 2 1 plus alpha. So now here I've come to the form of my time evolved wave function. So now if we plug back in what is alpha, we said alpha back in, I think it was video number 2, we said that alpha is I h bar t over 2m. So now our wave function is 1 over pi to the 1/4, the square root of 1 plus I h bar t over 2m, e to the minus x squared over 2 to the 1 plus I h bar t over 2m. So this is our final answer right here. So how does that compare with what we did in class? Well, in class, we came up with the general solution that uxt was pi to the 1/2 power times delta plus I to the h bar t over 2, over m times delta, all of that to the minus 1/2 power, times e to the minus x minus initial momentum t over m, quantity squared, divided by 2 delta squared 1 plus I h bar t over m delta squared times e to the I p0 over h bar x minus p0t over 2m. So that was the general case. If now p0 is equal to 0, delta is equal to 1, then this equation becomes 1 over the delta here is equal to 1. So you get 1 over pi to the 4th. So square root of pi to the minus 1/2 power times 1 plus I h bar t over m, which is the same as what we got from this exercise. Now E, okay, this term right here, P0 is 0, so that drops out. Delta is equal to 1, and so we get e to the minus x squared over 2 1 plus I h bar t over m, and then p0 is 0, so this term right here just becomes 1. And so the question is, what did I made a mistake. In the previous one, alpha is not equal to 2m, so that's wrong. Alpha is actually equal to I h bar t over just m. So if I go back and try and correct it, there is no 2 right here, and there is no 2 right here. So that was my mistake. So in the end, what we get is the same solution, either using the original method of finding the propagator from what we did in class, or from setting the propagator equal to the exponential I, the Hamiltonian t divided by h bar. Sorry, minus I, the Hamiltonian t over h bar.